in general in section 3. Okay, but for right now we're just going to talk about extrema on a specific interval. So first of all, let's define what extrema actually are. Okay, let f be defined on an interval I containing c. Okay, so now that you're ultimately confused, it basically just means f is a point in the interval. It says f of c is the minimum of f if f of c, which is basically the value here, is less than all f of x. So basically minimum value means it's the lowest value. It's less than everything else. Okay, in this next statement it says f of c is the maximum of f on I if f of c is greater than or equal to f of x. So basically it's the maximum if it's the greatest value, if it's bigger than everything else in the interval. Okay, so the maximum and minimum of a function on an interval are the extreme values or extrema. Okay, so of the function on the interval, the minimum and maximum of a function on an interval are also called the absolute maximum and absolute minimum.
I'm your favorite.
Of course, she'll stop our lesson.
For brownies!
Okay, so if you notice, and this is really important, okay, this is really important that you understand this last statement. The minimum and maximum of a function on an interval are also called the absolute min and the absolute max on the interval. Okay, so absolute refers to an interval. Okay, that's really important to understand because we're going to talk about something known as a relative max and a relative min as well. Okay, so the extreme value theorem states that if f is continuous on a closed interval. So it basically means if you're looking at an interval of a graph, f will have both a min and a max on that graph, okay, or in that interval. And that should make sense. We're going to go ahead and look at a few examples of that, but that should make sense when we go through and look at the examples. So now what we're going to do is we're going to talk about relative extrema because these are different than absolute. Absolute occur on an interval, okay? The graph has a relative max and a relative min at the point 2, -4, okay? You don't need to know that point because what we're going to focus on is this next statement. Informally, you can think of a relative maximum as occurring on a hill, okay? And a relative minimum as occurring in a valley, okay? Such a hill and a valley can occur in two ways. If the hill or valley is smooth and rounded, the graph will have a horizontal tangent line at the high point or low point. Okay? If the hill or valley is sharp and peaked, the graph represents a function that is not differentiable. So, definition of relative extrema. If there's an open interval, so now this is saying if in any graph you have a hill or a valley, it will have a relative max and a relative min. Okay? Now, a graph can have multiple relative maxes and multiple relative mins, and that's what we're going to talk about. All right. So, definition of critical numbers. So, before we even get started with an example, we have to kind of define some things. The first is what's a critical number. Okay? A critical number occurs when the first derivative equals 0, or if the first derivative is undefined. So this is something to get down. Critical numbers occur when the first derivative is 0, or when the first derivative is undefined. That's where a critical number occurs. Now, you're going to need to find critical numbers throughout the entire chapter. That's a crucial part of this chapter. Okay? Now here's the key point. Why do we even need to find critical numbers? Because you can only have a max or a min occur at a critical number. So here's our guidelines for finding extrema on a closed interval. So this is what we're focusing on today, because today's just a closed interval. It's not an open interval. First of all, if we're going to find the extrema, we are going to find the critical numbers of f. So that means we've got to find the derivative, see where it equals 0 or where it's undefined. We're going to evaluate f at each of those critical numbers. Some cases, there might only be one. Okay. Then we're going to evaluate f at each endpoint. The least of these values is the minimum. The greatest will be the maximum. So let's go and look at an example. Okay, we're going to go through each of the steps. Okay, so the first step, I need to find the derivative. That's where we start. So the derivative of f of x. What? We've got to find the derivative. So what's the derivative of 3x to the 4th minus 4x cubed? 12x cubed minus 12x squared. Now, in order to find the extrema, I need to set that derivative equal to 0, because I'm going to find my critical numbers. So 0 equals. Now, in order to solve that for 0, I'm going to need to factor in this case, because I notice that each of these terms contains a 12 and an x squared. So if I take 12x squared from 12x cubed, I get x minus 1. So now, according to our zero product property, which is something you learned way back in algebra, in order for this statement to be true, either 12x squared equals 0 or x minus 1 equals 0. Now, are you going to necessarily need to write that down every time? Probably not. You're going to be able to look at the dark blue step and you're going to be able to say what your critical numbers are. Okay, so in fact, what are my critical numbers? And 0. Your first critical number here will be 0, right? Because if you divide by 12 and then take the square root, basically, if you just have like a variable involved there, it's going to be 0. Okay, my second critical number here will be 1. These are my critical numbers. Okay? So now, what was the next step after we found our critical numbers? What did your guidelines say? Evaluate f at each critical number. So that means I'm going to plug 0 into f of x. Okay, so I get f of 0, which is 3 times 0 to the 4th minus 4 times 0 cubed. Now, do you necessarily need to write that out? No. The reason why I did that is so you understand I'm putting it into the original equation and not the derivative. So what's the value they're going to be? 0. Now you can do the same thing with 1. So I'm going to take 3 times 1 to the 4th minus 4 times 1 cubed. And what one will that be? Negative 1. So now I've evaluated f at each critical number. Next step was to do what? Evaluate f at each endpoint. Here are my endpoints, right here. Okay, so now I'm going to find f of negative 1. So I've got 3 times negative 1 to the 4th minus 4 times negative 1 cubed. Now be careful on this one. What's your answer actually going to be on this one? 7. Because it's going to be 3 minus negative 4. And then I'm going to find f of what? 2. So I'm going to have 3 times 2 to the 4th, because that's the second endpoint that I have, minus 4 times 2 cubed. So what do we end up having here? 48 minus 32. So your answer is 16. So once you do that, these are all my possible max and min values. The biggest one is going to be the max. So here is going to be my max. So really, I've got a max at, now we don't just leave it like that. I actually answer it as a specific point. And the specific point here will be this value first, and then this value last. So a max at 216. What's your minimum going to be at? Yep, 1, negative 1. So here's your min. Okay. So that you're done. That's the problem. You found your max and your min. Now, what that one theorem, the extreme value theorem, guaranteed is that if you have a closed interval, you're going to have both a max and a min. So that's why we answer both. Questions?
Bees knees.
Okay, let's look at another one. Okay, f of x equals 2x minus 3x to the 2/3 power. We're looking on the interval -1 and 3.
First, derivative. Let's do it.
So let's find the first derivative. So f prime of x equals,
2.
Yep.
2
Over x
x
and 1/3.
over x to the 1/3.
okay, so 2 over x to the 1/3. So now in order to solve this and find critical numbers, I need to set this equal to 0. Okay, I'm going to show you a way to solve this. Okay, what I would do is I would add 2 over x to the 1/3 to both sides. Okay, so basically I'm going to move this 2 over x to the 1/3 over here to the left. So I get 2 over x to the 1/3 equals 2. Why do you suppose I did that? Yeah, because now you can cross multiply. Okay, let's write a proportion right here, and then cross multiply. So really I get 2x to the 1/3 equals 2. So what does x to the 1/3 equal? 1. So what's your critical number going to be? 1. Now, that's partially correct. There is another critical number. Does anybody know what it is?
0.
Why is it 0?
Because there is yeah.
What happens at 0? If I plug 0 in here,
Oh.
what is it? What happens to the derivative? I get 0 on the bottom, which means your derivative is what? Undefined. So when you get an instant like this of where you're going to get a denominator, this is where your derivative is undefined, so this is why you need to include 0. So that's one of those things that's really important that you understand. Okay?
How'd you get from x to 1/3 equals 1 to
Okay, let me
x
put this
equals 1?
critical numbers. How did I get what?
How'd you get from the blue step to the green step?
The blue step to the green step. Okay? This is equals 2, right? So one of the things that we could do is we could cross multiply if we wanted, or I could just multiply both sides by x to the 1/3. It's the same thing.
Okay, how'd you get
Okay.
x to the 1/3 equals 1?
Now, x to the
To
1/3
x
equals
equals
1 to x equals 1. In order to undo something that's to the 1/3 power, I'm going to cube both sides, because that will get rid of that 1/3 power. Okay? And so it's kind of like if you had the square root of something, you would square both sides. If you have like the 1/4 power, you would take the 4th to both sides. Okay? And so then 1 cubed is 1. Does that make sense? Now this is a little bit more in depth. I mean, you're not going to have a lot of these that are going to be like this. Okay, but understand if you've got a denominator with a variable, you're probably going to need to include 0. Okay. So now we're going to evaluate f at each of the critical numbers. So I've got to find f of 0 and f of 1. Now I'm not plugging it back into the derivative, I'm plugging it back into the original problem. So in this case, I've got 2 times 0 minus 3 times 0 to the 2/3. Well, what's that going to be? 0, okay? F of 1, you're going to have 2 times 1 minus 3 times 1 to the 2/3. So now, you can do these on your calculator, but you need to be really careful how you do the power. You're going to do this. That's how you do 1 to the 2/3 power. And that one will be -1 because it's 2 minus 3. But just file this away to memory. When you're doing powers like that, you need to make sure you put those in parentheses. Okay, so let's go ahead and find f of, what's next? Perfect, f of -1 and then f of 3. Okay, so this is where, if you're doing this on your calculator, okay, I've got 2 times -1, which is great, minus, this is where you need to be careful. Okay, -1 caret 2/3. That's how you need to enter it in. That -1 needs to be in parentheses because otherwise it's just going to attach. You got -1 on that one? Somebody else get -1?
I got one.
Got it. And then
-5 is your answer. Okay. And this is why. If you do -1 to the 2/3, you should get a +1. So basically, it's like -2
Oh,
minus
the
3.
answer, duh.
Yeah, the answer. Oh,
Guys,
okay.
it's just in there.
All right. What is f of 3? And you will get a decimal here. -0.24. Good job. Okay, -0.24. So now we need to go ahead and say what the min and the max are.
Minimum would be -5.
Minimum's -5, okay? And the maximum is 0. So now we need to go ahead and write those out. So I've got a min at what point? -1, -5, nice job. And then I've got a max at what point? 0, 0. Nope. This means the graph's probably below the y-axis a lot. Okay, so far so good? Alrighty. I think I'm going to leave that one to probably Monday. I want you to go ahead and get started. There you go, pages 169 to 170. Okay, 1, 2, 9 through 14, 19 through 29 odds, and 37 through 39. Now 37 through 39, we might have to look at on Monday to kind of get you started with things. Okay, but real quick, I want you to go to 9 through 14 right now. Actually, let's start with 1 and 2 on page 169 so that you know kind of what's going on. Where? 1 and 2. All right, so we're ready for 1 and 2?
That's a lot of comments per paragraph.
Okay, on 1 and 2, what they want you to do on 1 and 2 is they want you to specify is, like point A, an absolute min, an absolute max, a relative min, or a relative max. Okay? So this is the thing. Something is an absolute max if that is the absolute highest point on the graph. Something is an absolute min, in this case, if it is the absolute lowest point on the graph. Now, if there's like a hill, that's a relative max. If there's like a valley, that's a relative min. Okay, so that's what you're going to do on 1 and 2.
No matter, even if it like E for an example, that would be a relative max. Even though it's
That-
not even
yes.
close to the top.
Yes. Okay, a relative max refers to a hill. Now, the reason why that's a relative max is because there's actually a horizontal tangent line there, and there's a critical number there at E. So that will give you a maximum value. I'm going to tell you something. D is not
What the heck?
an absolute min
Is F
because
is
it's
colored?
open, because the circle is not
What is it
colored
then?
in. It's nothing. It's neither.
So G be neither too, and A? Because
G and A are both neither, yes.
What? Doesn't have anything
Because you don't know. A and G are just your endpoints. They are not like a specific high point or a specific low point. You can't conclude what A and G are. So now 9 through 14. 9 says approximate the critical numbers of the function shown in the graph. This is what you're going to do on number 9. All you need to do is tell me where the critical numbers occur. The critical numbers occur where the graph has a sharp turn, where the graph is not continuous, or where the graph has a horizontal tangent line. Remember those 3 things from chapter 2. So that's where your critical numbers will occur. Okay? On 13 and 14, you actually just need to find the critical numbers. So find the first derivative, set it equal to 0. So that should get you going. So